Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math P4 Variant 2 October-November 2020. Let's get started. Carol traveled from London to Johannesburg and then from Johannesburg to Windhoek. The flight from London to Johannesburg took 11 hours 10 minutes. The average speed was 813 kilometers per hour. Calculate the distance traveled from London to Johannesburg. Give your answer correct to the nearest 10 kilometers. To find the distance traveled from London to Johannesburg, we need to know the speed and the time taken for the journey, which have all been provided in the question. The speed has been given as 813 kilometers per hour and the time duration is 11 hours 10 minutes. To convert 10 minutes to hours, we divide it by 60. When we type this into the calculator, we get 9078.5 kilometers. We need to round off this number to the nearest 10 kilometers. So we look at the number in the tens column, which is 7. The number after 7 is greater than 5. So we add 1 to 7 and the numbers after 7 become 0. So we have 9,080 kilometers, correct to the nearest 10 kilometers. The total time for Carol's journey from London to Windhoek was 15 hours 42 minutes. The total distance traveled from London to Windhoek was 10,260 kilometers. Calculate the average speed for this journey. This time around, we've been given the distance and time duration for the entire journey, and we are asked to find the average speed. We know that speed equals distance over time. The distance traveled is 10,260 kilometers, and the time duration is 15 hours 42 minutes. To convert 42 minutes to hours, we divide it by 60. When we type this into the calculator, we get the speed of the journey as 654 kilometers per hour. The cost of Carol's journey from London to Windhoek was $470. Calculate the distance traveled per dollar. To get this value, we divide the total distance traveled from London to Windhoek, which was given in the previous question as 10,260 kilometers, by the total cost of the journey, which is $470. When we type this into the calculator, we get 21.8 kilometers per dollar. Calculate the cost per 100 kilometers of this journey. Give your answer correct to the nearest cent. First, let's set up our ratio. If the total journey, which is 10,260 kilometers, costs $470, then for 100 kilometers, how much will it cost? This is what we've represented with X. From this ratio, we can set up an equation to find X. This gives us X equals 100 kilometers divided by 10,260 kilometers times $470. When we type this into the calculator, we get $4.58, which is correct to the nearest cent. Since 1 cent is $0.01, this is the same as correcting the final answer to 2 decimal places. Carol changed $300 into 3,891 Namibian dollars. Complete the statements. We can choose to set up a ratio for the given scenario. If $300 gives us 3,891 Namibian dollars, then how much will $1 give us? This is what we are representing with X. From the ratio, we set up an equation for X, which gives us $1 divided by $300 times 3,891 Namibian dollars. When we type this into the calculator, we get 12.97 Namibian dollars. Describe fully the single transformation that maps triangle T onto triangle P. When we look at both triangles, we can straight away tell that this is a translation because both triangles have equal side lengths and they have the same orientation. The only difference is they are located on different parts of the grid. So now we need to find the translation vector that allows us to move from triangle T to triangle P. From the illustration, we can see that this vector is 1, -6. And so the full description for this transformation will be translation by the vector 1, -6. Reflect triangle T in the line x equals 1. First, we need to draw the line of reflection, which is x equals 1. Then we reflect each vertex on triangle T in the line x equals 1. This means if we pick point A, since we move 1 unit to the left to touch the line of reflection, we also need to move 1 unit to the left from the line of reflection to pin the new position of point A. After repeating the same process for all the vertices on triangle T, we are now able to map out the reflected image of triangle T. Rotate triangle T through 90 degrees anticlockwise about 60. First, we need to mark the center of rotation. Then we rotate each vertex on triangle T 90 degrees anticlockwise about this center. This means if we pick point B, we draw a line from point B to the center of rotation. Then we measure and mark 90 degrees in the anticlockwise direction from this line. From here, we draw a line from the center of rotation passing through the 90-degree mark. The final step is to now mark the new position of point B on this line such that the distance from this new position to the center of rotation is the same as the distance from the center of rotation to the original position of point B. After repeating the same process for all the vertices on triangle T, we are now able to map out the rotated image of triangle T. Enlarge triangle T by a scale factor of -2, center 10. First, we need to mark the center of enlargement. Then we need to move each vertex on triangle T such that we are able to produce the enlarged image of the triangle. Let's pick point C. To move from the center of enlargement to point C, we move 2 units up and 4 units to the right. And so to pin the new position of point C, we move in the opposite direction due to the negative scale factor. So instead of going up, we go down. And since the scale factor is 2, we move twice the number we moved initially. Initially, we moved 2 units up. This means we are going to move 4 units downwards. And instead of moving 4 units to the right like we did initially, we are rather going to be moving 8 units to the left. After repeating the same process for all the vertices on triangle T, we are now able to map out the enlarged image of triangle T. Beth invests $2,000 at a rate of 2% per year compound interest. Calculate the value of this investment at the end of 5 years. By applying the compound interest formula, the final value of the investment will be the initial amount invested, which is $2,000, times 1 plus the rate, which has been given as 2%, raised to the power 5, which is the duration for the investment. When we type this into the calculator, we get $2,208.16. Calculate the overall percentage increase in the value of Beth's investment at the end of 5 years. The percentage increase is equal to the increase in the value of the investment, which is $2,208.16 minus $2,000, divided by the initial value of the investment, which is $2,000, times 100%. When we type this into the calculator, we get 10.408%. Calculate the minimum number of complete years it takes for the value of Beth's investment to increase from $2,000 to more than $2,500. This time around, we need to find the value of t from the compound interest formula. Given that the final value of her investment is $2,500, the initial value is $2,000 and the rate is 2%. 1 plus 2 over 100 is the same as 1.02. And when we divide both sides of the equation by 2000, this is what we get. By applying the basic definition of log, we are able to easily find the value of t by rewriting this as t equals log of 1.25 to the base of 1.02. When we type this into the calculator, we get 11.26. This means for Beth's investment to reach more than $2,500, it takes more than 11 years. And so this means the minimum number of complete years it takes is 12 years. The population of a village decreases exponentially at a rate of 4% each year. The population is now 255. Calculate the population 16 years ago. We are going to apply the compound interest formula in this case as well, due to the keyword exponential. Since the population is decreasing, we bring minus here instead of a plus. Big A represents the final population value, which is 255. Small a represents the initial population value, which is what we are finding. R is the rate, and that is 4. T is the time duration, which has been given as 16. When we make small a the subject, this is what we get. And when we type this into the calculator, we get 490. The height h centimeters of each of 120 plants is measured. The cumulative frequency diagram shows this information. Use the cumulative frequency diagram to find an estimate of the median. To get the median, we map half of 120, which is 60, on the diagram. This gives us the median to be 25 centimeters. Find an estimate of the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. To get the upper quartile, we map 3/4 of 120, which is 90, on the diagram. This gives us the upper quartile to be 32 centimeters. For the lower quartile, we map 1/4 of 120, which is 30, on the diagram, giving us 22 centimeters as the lower quartile. So now the interquartile range is 32 minus 22 centimeters, which is 10 centimeters. Find an estimate of the 60th percentile. To get the 60th percentile, we map 60% of 120, which is 72, on the diagram. This gives us 27 centimeters. Find an estimate of the number of plants with a height greater than 40 centimeters. On the diagram, when we map 40 centimeters from the horizontal axis to the cumulative frequency graph, we get 114, which represents the number of plants with a height of 40 centimeters or less. Therefore, to get the number of plants with a height greater than 40 centimeters, we subtract 114 from the total number of plants, which is 120. 120 minus 114 is 6. The information in the cumulative frequency diagram is shown in this frequency table. Calculate an estimate of the mean height. The mean is equal to sigma f of x, which is the total sum of the heights of all the plants, divided by sigma f, which is the total number of plants. To get sigma f of x, we first need to calculate the average height of the given height intervals. For the first interval, the average height is 0 plus 10 divided by 2, which is 5. Then we have 10 plus 20 divided by 2, which is 15. 20 plus 30 divided by 2, which is 25. Then finally, we have 30 plus 50 divided by 2, which is 40. So now, sigma f of x is 5 times 2 plus 15 times 18 plus 25 times 62 plus 40 times 38, and sigma f is 120. When we type this into the calculator, we get the mean as 27.9 centimeters, correct to 3 significant figures. A histogram is drawn to show the information in the frequency table. The height of the bar representing the interval h is greater than 10 and less than and equal to 20 is 7.2 centimeters. Calculate the height of the bar representing the interval h is greater than 30 and less than and equal to 50. The frequency density gives us the height of intervals on the histogram. For the interval h is greater than 10 and less than and equal to 20, the frequency density is equal to the frequency, which has been given as 18 from the previous table, divided by the interval width, which is 20 minus 10. This gives us 1.8. Since the height of the interval drawn on the histogram is 7.2 centimeters, then it means 1.8 times a certain scale factor should be equal to 7.2. This scale factor is 4. So for the interval h is greater than 30 and less than and equal to 50, its height will be 4 times the frequency density, which is 38 divided by 50 minus 30. This gives us 7.6 centimeters. Ahmed sells different types of cake in his shop. The cost of each cake depends on its type and its size. Every small cake costs X dollars and every large cake costs 2x plus $1. The total cost of 3 small lemon cakes and 2 large lemon cakes is $12.36. Find the cost of a small lemon cake. The total cost of the lemon cakes, which is $12.36, is equal to 3 times x plus 2 times 2x plus 1, where x is the cost of a small lemon cake. From here, all we need to do is find the value of x. When we expand the brackets, 2 times 2x is 4x and 2 times 1 is 2. When we group like terms, 3x plus 4x is 7x and 12.36 minus 2 is 10.36. When we divide both sides by 7, we get x equals 1.48. The cost of 18 small chocolate cakes is the same as the cost of 7 large chocolate cakes. Find the cost of a small chocolate cake. We've been told that the cost of 18 small chocolate cakes, which is 18x, is equal to the cost of 7 large chocolate cakes, which is 7 times 2x plus 1. X is the cost of a small chocolate cake, so all we need to do is make x the subject of the equation. When we expand the brackets, 7 times 2x is 14x. 7 times 1 is 7. When we group like terms, we get 4x equals 7. When we divide both sides of the equation by 4, we have x equals 7 over 4. 7 over 4 in decimal is 1.75. The number of small cherry cakes that can be bought for $4 is the same as the number of large cherry cakes that can be bought for $13. Find the cost of a small cherry cake. The number of small cherry cakes that can be bought for $4 is $4 divided by the unit cost of a small cherry cake, which is X dollars. The number of large cherry cakes that can be bought for $13 is $13 divided by the unit cost of a large cherry cake, which is 2x plus $1. From the equation, 4 over x is equal to 13 over 2x plus 1. We want to find the cost of a small cherry cake, which is x, and so we need to make x the subject of the equation. When we cross multiply, we get 4 times 2x plus 1 equals 13x. When we expand the brackets, 4 times 2x is 8x and 4 times 1 is 4. When we group like terms, we get 5x equals 4. When we divide both sides by 5, we get x equals 4 over 5. 4 over 5 in decimal is 0.8. Petra spends $20 on small coffee cakes and $10 on large coffee cakes. The total number of cakes is 45. Write an equation in terms of x. Solve this equation to find the cost of a small coffee cake. Show all your working. The number of small coffee cakes Petra buys is equal to the amount she spent on small coffee cakes, which is $20, divided by the unit cost of a small coffee cake, which is x dollars. The number of large coffee cakes she buys is equal to the amount she spent on large coffee cakes, which is $10, divided by the unit cost of a large coffee cake, which is 2x plus $1. From the question, the number of small coffee cakes Petra buys, which is 20 over x, plus the number of large coffee cakes, which is 10 over 2x plus 1, is equal to 45. So now we need to solve this equation. When we multiply through the equation by x times 2x plus 1, this is what we get. When we expand the two brackets, this is what we get. From here, we move all the terms to one side of the equation and group like terms to give us the quadratic equation 90x squared minus 5x minus 20 equals 0. The terms have a common factor of 5. So when we divide through the equation by 5, we have 18x squared minus x minus 4 equals 0. We can solve this quadratic equation by factorization. We can rewrite negative x as negative 9x plus 8x. When we factor out 9x from the first two terms, we are left with 2x minus 1. And when we factor out 4 from the final two terms, we are left with 2x minus 1. This equation can be rewritten as 9x plus 4 times 2x minus 1 equals 0. When we equate 9x plus 4 to 0, we get x equals negative 4 over 9. And when we equate 2x minus 1 to 0, we get x equals 0.5. The value of x is the price of a cake and cannot be negative. Therefore, x is equal to $0.5. The diagram shows 6 discs. Each disc has a color and a number. One disc is picked at random. Write down the probability that the disc has the number 4. This probability is equal to the number of discs with the number 4, which is 2, divided by the total number of discs, which is 6. So our final answer here can be written as 2 over 6, or simplified to 1 over 3. Write down the probability that the disc is red and has the number 3. Straight away, we know that this probability is equal to 0 because there is no disc that is red and has the number 3. Write down the probability that the disc is blue and has the number 4. This probability is equal to the number of discs that are blue and have the number 4, which is 1, divided by the total number of discs, which is 6. And so our final answer here is 1 over 6. 2 of the 6 discs are picked at random without replacements. Find the probability that both discs have the number 3. For the first pick, the probability that a disc with the number 3 is picked is equal to the number of discs that have the number 3, which is 2, divided by the total number of discs, which is 6. Since the first disc is not replaced, the pool reduces by 1. And so for the second pick, the probability of picking a disc with the number 3 is 1 over 5. When we type this into the calculator, we get 1 over 15. Find the probability that both discs have the same color. This probability has two scenarios. In the first scenario, two yellow discs are picked, and in the second scenario, two blue discs are picked. The probability of picking a yellow disc in the first pick is 2 over 6. Without replacement, the probability that the second disc is also yellow is 1 over 5. The probability of picking a blue disc first is 3 over 6. Without replacement, the probability of picking a blue disc the second time is 2 over 5. When we type this into the calculator, we get 4 over 15. 2 of the 6 discs are picked at random with replacements. Find the probability that both discs have the same color. This probability has three scenarios: picking red twice, picking yellow twice, and picking blue twice. The probability of picking a red disc the first time is 1 over 6. If the disc is replaced, the probability of picking a red disc again is still 1 over 6. The probability of picking a yellow disc the first time is 2 over 6. If this disc is replaced, the probability of picking a yellow disc again is still 2 over 6. The probability of picking a blue disc the first time is 3 over 6. If this disc is replaced, the probability of picking a blue disc again is 3 over 6. When we type this into the calculator, we get 7 over 18. Y equals x squared plus 1 over x, where x can never be equal to 0. Complete the table. When we substitute x equals 1 into the equation, we get y equals 2. And for x equals 2, we get y equals 4.5. On the grid, draw the graph of y equals x squared plus 1 over x for x is greater than and equal to 0.2 and less than and equal to 2.5. The graph of y equals x squared plus 1 over x for x is greater than and equal to negative 2.5 and less than and equal to negative 0.2 has been drawn for you. On the grid, we plot all the points in the table and draw a smooth line passing through the points. By drawing suitable straight lines on the grid, solve the following equations. X squared plus 1 over x equals negative 2. From this equation, we have the equation of the curve on one side of the equation and negative 2 on the other side of the equation. This means that the line we need to draw on the grid is y equals negative 2. When we draw y equals negative 2 on the grid and read the x coordinates of its intersection point with the curve, we get negative 0.45. Solve the equation x squared plus 1 over x plus x minus 1 equals 0. First, we need to rearrange the equation to leave the function of the curve on one side of the equation. This gives us the equation of the curve, which is x squared plus 1 over x equals 1 minus x. This means we need to draw the line y equals 1 minus x on the grid. When we draw the line y equals 1 minus x on the grid and read the x coordinate of its intersection point with the curve, we get negative 1.85. K is an integer and the equation x squared plus 1 over x equals k has three solutions. Write down a possible value of k. In this case, we need to find the line y equals k that intersects the graph at 3 points. From the graph, we see that one of these lines is y equals 4. The points A, B, C, D, and E lie on the circle. PAQ is a tangent to the circle at A, and EC equals EB. Angle ECB equals 80 degrees and angle ABE equals 40 degrees. Find the values of V, W, X, Y, and Z. Based on the alternate segment theorem, if this angle is 40 degrees, then angle V should also be equal to 40 degrees. Chord AE subtends 40 degrees at the circumference of the circle and also subtends angle X at another point on the circumference. This means X should also be equal to 40 degrees. ABCE is a cyclic quadrilateral. Opposite angles y and 80 degrees should add up to 180 degrees. So when we subtract 80 degrees from 180 degrees, we get the value of y as 100 degrees. In the question, we were told EC and EB have equal lengths, which makes triangle BCE an isosceles triangle. Base angles in an isosceles triangle are equal. This means W is also equal to 80 degrees. ABCD is another cyclic quadrilateral. Opposite angles should add up to 180 degrees. This means Z plus 40 degrees plus W, which we found as 80 degrees, should be equal to 180 degrees. And so when we make Z the subject of the equation, we get the value of Z as 60 degrees. In the diagram, K, L, and M lie on the circle center O. Angle KML equals 2x degrees and reflex angle KOL equals 11x degrees. Find the value of x. Chord KL extends an angle 2x degrees on the circumference of the circle and extends another angle at the center of the circle. This means that the angle at the center is 2 times 2x degrees, which is 4x degrees. Angles around the point add up to 360 degrees, so we have 4x plus 11x equals 360. 4x plus 11x is 15x. When we divide both sides of the equation by 15, we get x equals 24. The diagonals of the cyclic quadrilateral ABCD intersect at x. Explain why triangle ADX is similar to triangle BCX. Give a reason for each statement you make. Vertically opposite angles are equal, therefore angle AXD is equal to angle BXC. Angles in the same segment are equal. This means angle DAX and angle CBX are equal. This also means angle ADX and angle BCX are equal. Since we've shown that corresponding angles in both triangles are equal, then they are similar triangles. AD is 10 centimeters, BC is 8 centimeters, BX is 5 centimeters, and CX is 7 centimeters. Calculate DX. We've shown that triangle ADX is similar to triangle BCX. This means that the ratio of their corresponding lengths are equal. So we have DX divided by CX equals AD divided by BC. When we make DC the subject of the equation and substitute the values of AD, BC, and CX, this is what we get. When we type this into the calculator, we get DX equals 8.75 centimeters. Calculate angle BXC. Since we know all the side lengths of triangle BXC, we can easily find angle BXC by using the cosine rule. This is what we get when we apply the cosine rule to triangle BXC. When we make angle BXC the subject of the equation, this is what we get. Now we can substitute the values of BC, BX, and CX into the equation and type it into the calculator. This gives us 81.8 degrees rounded to 1 decimal place. The diagram shows a prism with a rectangular base ABFE. The cross-section ABCD is a trapezium with AD equals BC. AB is 8 centimeters, GH is 5 centimeters, BF is 12 centimeters, and angle ABC is 70 degrees. Calculate the total surface area of the prism. This is the equation for the total surface area of the prism. The area of ABCD is the same as the area of EFGH, so we multiply this area by 2. The area of BCFG is the same as ADHE, so we also multiply this area by 2. We already have the length and width of rectangle ABFE, and so its area will be 8 times 12 centimeters squared, which is equal to 96 centimeters squared. The area of DCHG is 5 times 12 centimeters squared, which is equal to 60 centimeters squared. We know the length of BCFG, which is 12 centimeters. However, we've not been given its width BC. We can find the length of BC using SOHCAHTOA. This gives us cos 70 degrees equals 1.5 centimeters divided by BC. When we make BC the subject, this is what we get. And so the area of BCFG is 12 times 1.5 divided by cos 70 degrees. When we type this into the calculator, we get 52.628 centimeters squared. ABCD is in the shape of a trapezium. The top length of the trapezium is 5 centimeters and the bottom length is 8 centimeters. We've not been given the height of the trapezium, but we can find it using SOHCAHTOA. This gives us tan 70 degrees equals h divided by 1.5 centimeters. When we make h the subject, this is what we get. And so the area of ABCD is half of 5 plus 8 times 1.5 times 70 centimeters squared. When we type this into the calculator, we get 26.788 centimeters squared. When we put the values of all these areas into the original equation, this is what we get. When we type this into the calculator, we have 315 centimeters squared rounded to 3 significant figures. The perpendicular from G onto EF meets EF at X. Show that EX equals 6.5 centimeters. On the diagram, we've indicated the position of point X. We see that EX is EF minus FX. EF is 8 centimeters and FX is 1.5 centimeters. 8 minus 1.5 is 6.5. Calculate AX. On the diagram, we've drawn the line from A to X with a green arrow. This line forms the hypotenuse of the right-angled triangle AEX. We already know AE is 12 centimeters and we found EX as 6.5 centimeters. Since we know these lengths, we can find AX using the Pythagoras theorem. This gives us AX squared equals AE squared plus EX squared. When we make AX the subject of the equation and substitute the values of AE and EX, this is what we get. When we type this into the calculator, we get 13.6 centimeters rounded to 3 significant figures. Calculate the angle between the diagonal AG and the base ABFE. On the diagram, we've drawn the line from A to G with a pink line. This line forms the hypotenuse of the right-angled triangle AGX. We've labeled the angle between AG and the base as alpha. We can find alpha by applying SOHCAHTOA. This gives us tan alpha equals GX divided by AX. We found AX in the previous question as 13.6 centimeters. GX is the same value as H, which we found in part A as 1.5 times 70 centimeters. When we make alpha the subject of the equation and substitute the values of GX and AX into the equation, this is what we get. When we type this into the calculator, we get 16.9 degrees rounded to 1 decimal place. Find the value of f of 3. To get f of 3, we replace x with 3 in f of x. This gives us 3 squared plus 1, which is equal to 10. Find the value of g of f of 3. To get g of f of 3, we replace x in g of x with f of 3, which is 10. This gives us 1 minus 2 times 10, which is equal to negative 19. Find g inverse of x. We know that g of x is equal to 1 minus 2x. So in the first step, we replace g of x with x and replace x with y. When we make y the subject of the equation, this is what we get. This expression for y is the same as g inverse of x. And so g inverse of x is also equal to 1 minus x over 2. Find x when h of x is equal to 2. H of x is 1 over x, so we have 1 over x equals 2. When we multiply both sides by x, we get 2x equals 1. Now when we divide both sides of the equation by 2, we get x equals 0.5. Find g of x times g of x minus g of x. Given your answer in the form ax squared plus bx plus c. G of x times g of x is 1 minus 2x times 1 minus 2x. For g of x, we replace x in g of x with g of x, which is 1 minus 2x. This gives us 1 minus 2 times 1 minus 2x. When we expand the brackets for 1 minus 2x times 1 minus 2x, we get 1 minus 4x plus 4x squared. 1 minus 2 times 1 minus 2x simplifies to 4x minus 1. When we group like terms, minus 4x minus 4x is minus 8x, and 1 minus negative 1 is 2. And so our final answer here is 4x squared minus 8x plus 2. Find h of x. Given your answer in its simplest form. To get h of x, we replace x in h of x with h of x, which is 1 over x. So 1 over x becomes 1 times x over 1, which is equal to x. Find j of 5. For j of 5, we replace x in j of x with 5. This gives us 5 raised to the power 5, which is equal to 3125. Find x when j inverse of x equals 2. To get j inverse of x, we replace j of x with x and replace x with y. Y is the same as j inverse of x, which has been given as 2. And so we have x equals 5 raised to the power 2, which is equal to 25. J of x equals h of g of negative 12. Find the value of x. First, let's find g of negative 12 by replacing x in g of x with negative 12. This gives us 25. And so if j of x equals h of g of negative 12, then we know j of x is 5 raised to the power x, and h of g of negative 12 is 1 over 25. We can rewrite 25 as 5 squared. 1 over 5 squared is the same as 5 raised to the power negative 2. Since the bases on both sides are equal, then their powers should also be equal, and so x equals negative 2. Complete the table for the 3 sequences. The terms in sequence A have a common difference of negative 4, and so to get the 5th term, we subtract 4 from 1, which gives us negative 3. The nth term for a sequence with a common difference can be expressed with this formula. A1 is the first term, which is 13. D is the common difference, which is -4. When we simplify this equation, we get the nth term as 17 minus 4n. For sequence B, we have a cubic sequence. For the first term, 1 cubed minus 1 is 0. For the second term, 2 cubed minus 1 is 7. And so for the fifth term, 5 cubed minus 1 gives us 124. And for the nth term, we have n cubed minus 1. For sequence C, the numerators have a common difference of 1 and the denominators have a common ratio of 2. And so to get the numerator for the fifth term, we add 1 to 10, which gives us 11. And for the denominator, we multiply 64 by 2, giving us 128. The sequence in the numerators can be expressed with this formula, and the sequence for the denominators can be expressed like this. In the numerator, A1 is 7 and D is 1. For the denominator, A1 is 8 and R is 2. When we simplify this equation, we get the nth term for sequence C as n plus 6 divided by 2 raised to the power n plus 2. One term in sequence C is P over Q. Write down the next term in sequence C in terms of P and Q. To get the next term, we add 1 to the numerator, giving us P plus 1, and we multiply the denominator by 2, giving us 2Q. And so our final answer is P plus 1 over 2Q. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.